Now let's talk about the J matrix. A J matrix is just a matrix of ones. So this 3 by 3 J matrix is a 3 by 3 matrix of just ones. And the reason why they call it a J matrix is because it just has ones. Actually, I don't know if that's true, but it can help you remember. Now, when you pre-multiply a matrix like 5 by 3 matrix Y, which we did in the previous video, by a 5 by 5 J matrix, you create a 5 by 3 matrix of the sums of each of the columns in Y. Each row is a repeat of those sums. So let me kind of demonstrate what I just said. So let's have J times our Y. And J this time is going to be a 5 by 5 matrix of ones. And doing larger one of these just make you crazy sometimes. Okay, and our Y was a 5 by 3 matrix, 5, 0, 9, 8, 7, 6, 6, 7, 8, 4, 5, 10, and 2, 1, 7. So this 5 by 5 times a 5 by 3, that will give us another 5 by 3. And when you do this, like I said before, when you pre-multiply a matrix like this one times a J matrix, you create a 5 by 3 matrix in this case of the sums of each of the columns of Y. So the sum of this actually is 25. Okay? And the sum of the second column is 20, and the sum of the third column is 40. And because we need a 5 by 3 matrix, we'll actually get these sums all the way down. So the row is just a repeat. Each row is a repeat of these sums. Okay? Now if you just want column sums and you don't want something like this, you can pre-multiply by a 1 by 5 transpose vector to get a single vector of the column sums. So let's do J times Y in the transpose of J. Okay, just a 1 by 5, and you multiply that by Y. Oops, didn't make it big enough. Okay, and what you'll get is just the sums. So that's an easy way to do that if you don't want to write all this out and all you want is the sums. Now when you post-multiply Y by J, you'll do a 3 by 3 J matrix, and that will create a 5 by 3 matrix of sums of the rows in Y. And each column is a repeat of these sums. So it's very similar to this, just the other way around. 5, 0, 9, 8, 7, 6, 6, 7, 8, 4, 5, 10, and 2, 1, 7. We're going to do a 3 by 3 in order to get this another 5 by 3 matrix. So just ones. And we're going to get a 5 by 3 matrix with the sums of rows. So you can sum this. This is 14. The next row sums to 21, then 21, 19, and this last row sums to 10. Now, what if you just want the row summations? So we'll do a similar thing as to what we did here. We're going to do matrix Y times this column vector J. by this time you get sick of writing y, but you've probably had it memorized by now. One, one, one. And we'll just get a column vector of the sums of rows, if that's what you want. And let's actually call this, excuse me, I'm going to call this one T, call this one transpose of T. We can call this one G if we want, and this is the vector G. So over here in Excel, I'm just going to go through this quickly again. We've all done matrix multiplication. I'm just going to demonstrate the answer. And once again, Excel is a good way to check your answers. So let's do J times Y. Oops. So as you notice, I actually did the wrong matrix first. Because we want to end up with a 5 by 3 matrix, we got to multiply this 5 by 5 matrix times y here. So let's do this again. So let's do M multiply this J matrix times this Y1. And we get that there. If you recall our 25, 20, 40 that we had before, now we're going to post multiply by J. So this Y, and we do the 3 by 3 one. And those are our row summations there. Now if we just want the column summations, we can do that over here. And if we want the row summations, we can do that over here. And just make sure you do the right ones. And we can extend that here. So now let's compare that with what we hand wrote over here. And as you see, we do have the same answers, both in Excel and what we did in handwriting. So that's a J matrix for you.